Hey, everybody. Thank you guys all for coming to CARTO locations. It's been a really great couple days, so I hope you've enjoyed it as much as I have. So I'm the product manager for our data observatory at CARTO, and we work with data day in and day out. And data science, machine learning, big data are all buzzwords that have been with us for years now. And you're familiar with the stats. Graphs like this that say the market size of big data is projected to grow from $33.5 billion in revenue in 2017 to $92.2 billion by 2026. And this graph that shows that everybody's doing it, or at least has been shamed into saying they're going to do it. And statements like this from Forbes, projecting that data monetization is becoming a major source of revenues as the world creation of data explodes to 180 trillion gigabytes of data by 2025. On the other side, we've also been seeing over the years less positive stories about data. More and more companies getting into trouble for improperly using or not properly protecting sensitive personal data. And everybody's probably sick at this point of hearing about the Cambridge Analytica and Facebook story that's just been going on in the news. So our approach to data stems from three overarching points. One, even though buzzwords do become tiresome, data is a powerful driver of market and organizational performance. And two, data has a dark side. So it becomes obvious in cases of breaches and misuse, and good stewardship and ethical standards are imperative. And three, most organizations are still really bad at handling their data. And in fact, if you can honestly tell me that you're doing a great job with your data, I will buy you a drink this afternoon at the conference and talk to you about it. But let's take a quick step back and ask why data is important. And we're all data people in this room, so I think we're all pretty convinced, but often we have to work with people who are not data people. And the word data, it's a convenient word, but it is perhaps too convenient. You hear it and it completely fails to evoke all of the possibilities carried within its meaning. And the word data is often alienating for some people. It sounds technical and abstract. It doesn't sound like it represents everything we're surrounded with and impacted by on a moment-to-moment basis. It makes us think of this instead of this. And as a side note, it's often pointed out that data itself is meaningless. As Clifford Stoll and others have said, it's only by converting data into information, and then converting that information into knowledge, and converting that knowledge into wisdom that it becomes meaningful. And I agree with that, certainly. But personally, when I say data, I am almost always referring to the data itself, as well as the process of converting it, and then the final outputs of information, knowledge, and wisdom. And I also often use the word data and information interchangeably, and will do so throughout this talk. So data allows us to see and understand the world in ways we ordinarily wouldn't have the ability to know. The more deliberately and creatively we use it, the more powerful it becomes. Whether we realize it or not, we're all constant creators and consumers of data. This constant data consumption is firstly just passive input. It's hot in here, this flower smells nice, I'm hungry. We observe it as a data input, and then we do something about it as a data output. Next, it's basic secondhand information. My friend just messaged me about a party, or according to this article, there's this thing going on. It's secondhand because we've received it from another source. It's basic because it comes very easily. Then we also respond to it and share it, which is a data output. Getting to the third level, it's kind of basic active information gathering. We go to school, we get training, we read, we practice. It's a lot of data coming at us. And then at the other end, our progress generates a lot of information, which is a data output. And at work, we're constantly consuming data, but it's often kind of the normal corporate data. Things like email chains, sales reports, budgets, expenses, employee lists, CRM information, calendars, and so on. And then our own day-to-day activities at the office contribute to this. And again, it's a data output. And up to this point, this is all individual data consumption and creation. And none of it seems like a big deal in the context of an individual. The information is important for each of us to just participate passively in society and the workforce. So 3 things to consider about that. 1, every step of the way, we're interacting with another person and company. And as the world becomes more digital, every bit of that interaction is stored somewhere and owned by somebody. 2, to consider step 2, we actually have to shift from a personal mindset to a company mindset. From a business point of view, how much of this constantly created digital information impacts your business, and how much are you making use of it? And 3, if you do plan to use it, are you fully aware of how personal a lot of this information is and what you need to do to safeguard it? Data drives performance because every future action is sparked by past information. The better we grasp that information, the better we can use it. The world is made up of a network of personal interactions. The more we digitize this, the more accessible personal information becomes, the more we have to take protecting it seriously. And while something like 2.5 quintillion bytes of data are produced per day, organizations are still struggling with the data problems that existed 10 years ago, not to mention struggling with the data challenges of today. And why is it worth getting a handle on these challenges? Albert Einstein once said, "We cannot solve our problems with the same thinking we use to create them." Now, one way to change our thinking is to reframe our thought process, something Albert Einstein was a great example of himself. The other way is to change our inputs. Feed our thought process with new and better information. And if organizations want to improve their output, they need to get a handle on this. So to start getting a handle on these old and new data challenges, creative and proactive information gathering is needed. And this is 1, finding creative new ways of using basic information, and 2, seeking out new ways, new information to create a more defined picture of the world around us. So, finding new ways of using existing data. Existing data like this stuff. First, make sure it's easy to use and updated frequently. How many hoops do you currently have to go through to get some data that you need, and how old is the data by the time you get it? Second, combine these data sets together to derive new insights. Some source joining is best as part of a planned data implementation. Other times, you'll use software that lets you pull things together on the fly. Sometimes it's just a plain old SQL query or VLOOKUP in Excel. The point is that data is more important, more valuable in the context of other data than it is on its own. Analytical models are important because our ability to understand data just by looking at it is limited. On our own, we can do a pretty good job of telling what happened or describing what happened in the past, but data is worth a lot more than that. And so as Stuart discussed in his talk yesterday, analytical models can be used to make predictions, inferences, and even determine the optimum course of action. And one example of this that I thought was pretty clever was a market intelligence company that took transcripts of quarterly corporate earnings calls, and they tested them against the Gunning Fog Index. And the Gunning Fog Index is a measure of sentence complexity. So it basically checks how many multi-syllabic words are used in a sentence. And they then checked that sentence complexity against company financial performance. And apparently, CEOs like to use big words when they're hiding bad performance. And rather than applying that knowledge just intuitively one call at a time, the calculation can be run over many transcripts and modeled against historical financial results to generate predictions when the next earning calls take place. The next step is to visualize and interact with the data. Get your hands dirty with it. Ask a question and interrogate the data until you find the answer, which will inevitably spark the next question, and keep going. And finally, use the data, this basic data, for things it's not usually used for. In financial services, they like to call it alternative data, which sounds like maybe complicated, but alternative data is often just ordinary data that's now used to inform investment decisions and make lots of money. And a classic example of this is a few folks from a hedge fund who watched corporate private jet schedules. And they noticed executives from two companies going back and forth between each other's headquarters. And though those companies had denied that there was going to be a merger, the investors went ahead and bet on it because of the data and won big. So that's using new ways, finding new ways of using existing data. Step 2 is seeking out new data sources. And sometimes it's not too far away, so there may be data within your own organization that can add context to what you're using now. But usually you'll need to look outside your organization and find out what else is out there that will complete the picture. And a lot of this data has only become available in recent years. Data enabled by the fact that our lives are increasingly digital. This is a constant and increasing flow of information we've never before had the opportunity to tap into. Data such as foot traffic data from anonymized mobile devices, credit card spend data, IoT devices, events, weather, sharing economy activities, and more. And all of this, the old data in new ways, the external data, the new data streams, come together to answer the question, what new inputs will help you ask and answer better questions, make new decisions, and expand your capacity to understand and solve problems? And of course, this is easier said than done. It can be difficult, time-consuming, and expensive. Reliable sources have to be found. Time must be spent shaping the data into a usable format. Careful expertise is needed to build the analytical models. These models then must be communicated effectively back to the people who need the information. And software has to be used for interactive visualizations as well as the cleaning and modeling process. So the good news is, we know that this data impacts many industries and people. So at CARTO, we've taken on the effort of sourcing it and preparing it and building the models and developing the visualization tools to make the insights more accessible. We've also been leading the conversation around privacy and ethical use. And this is all part of our new CARTO Data Streams offering that Javi talked about in his keynote yesterday. And instead of talking about this more, I think it's better to actually take a look at an actual example. And for that, I'll turn it over to my colleague and brilliant data scientist, Wen Fei.
Thank you, Hannah. So I'm going to walk through an example of how we can innovate through new location data streams. Or what I'd like to call the fun stuff. Or I guess if you're data nerds like us, that's how you like to think about it. So as Hannah mentioned in her presentation, here at CARTO, we're thinking about two aspects of location data streams. One is to find creative new ways to use more traditional data, and the other is to seek out new data sets in order to help us create a better picture of the world around us. So in other words, how do we answer old questions with new data and new techniques? So I'd like to present a fairly standard case study of how we can approach new old questions in new light. The city of Cambridge, Massachusetts, like many urban areas across the country, has undertaken a Vision Zero initiative to improve transportation and mobility conditions in the city by promoting public safety in the streets and reducing the number of traffic accidents across the city. So this potentially improves urban health and more equitable streets through encouraging more walking and biking. Can you scroll the text a little bit? Sorry. Yep, thank you. And so we can see here from this traffic accident heat map that many of the city's traffic accidents happen along Massachusetts Avenue, or Mass Ave, as it's informally called, that kind of long ellipse over there. To say that we've been tasked by the city to scope out a hypothetical car ban on Mass Ave during certain hours of the week to make it pedestrian only. They want us to select the best time of the day and the best week to make this happen, as well as scope out some of the potential impacts. Now, the standard traffic impact study looks at traffic volumes, patterns and peak hours, the distribution of trips, and travel modes. The bulk of these studies use manual and analog ways of counting people and vehicles, or they have to install physical sensors on the road. But the bottom line is, these methods are generally costly from a time, human, and financial resources perspective, and further, they're difficult to scale. And so by the way, going forward, I'm gonna refer to all vehicle activity, which includes like private cars and taxis, et cetera, as car activity, and all walking, running, biking as pedestrian activity. So through the data and methods that we're presenting today, we want to answer some standard questions in a traffic impact study. So for cars, we want to know how many trips currently go through the road, and thus how many vehicle trips are we potentially impacting? What's the trip trajectory of these vehicles? That is, where are the cars coming from and going to? And lastly, who are the drivers that are going to be impacted? So I think this last question actually goes beyond a typical traffic impact study, but with new data, we can estimate these characteristics. And in the spirit of promoting more equitable streets in the city, we want to make sure that we're not going to negatively impact more disadvantaged groups. For pedestrians, we want to answer a similar set of questions. How many pedestrians are currently on the road? What are the pedestrians where are the pedestrians coming from and going to? And who are these pedestrians? This will give us both a sense of who may benefit from this initiative and also help us understand how many more pedestrians you might see on Mass Ave if we find that pedestrians are generally coming from the neighborhood overall. And lastly, because Mass Ave is a commercial street, we want to understand the impact to the businesses here. So for the sake of time, I'm going to tell you that our hypothesis is that this initiative would probably positively impact businesses with more pedestrian traffic on the streets. But the question is, can we estimate how much? And then furthermore, what kinds of businesses are we going to impact? And I should also mention that for the sake of time, we're only going to look at the first order impact of the car ban and not any of the secondary impacts on the other streets that may see more traffic because of this initiative. So we're building our analysis on an open source municipal data set. CARTO is an open source software company, and we fundamentally believe in and rely on open source data as foundational to our product and to our data science offerings. Our municipal data set is the Cambridge Police Department's traffic crash report data, which are these points in red over here. This segment in blue is the section of Mass Ave between Harvard Square and MIT where we want to investigate. Now, using this data, we want to understand what's the best time of the day and what's the best day of the week to shut down traffic to vehicular activity. So using this crash data set, I can look at which days have the highest number of overall traffic accidents, and it looks like Friday just ekes out the other days in terms of both the mean and the median number of accidents. This shows the number of accidents per hour for each day of the week, and it seems like the time between 2 and 7 p.m. in the afternoon consistently have a higher number of accidents on Fridays. So from this information, we can look at the effects of closing down Mass Ave to cars on Fridays between 2 and 7 p.m. The next data set that we're going to bring into our analysis is new to the location intelligence world, anonymous mobile data, or foot traffic data, as we're calling it. And we hope to demonstrate in the next series of slides that this kind of data can be both a powerful and a very flexible resource. So first of all, why mobile data? There's a lot of background history here on the rise of information and communications technology, but instead I'll try to stick to the essentials, which is that mobile phone usage is ubiquitous. At almost 100% penetration in most developed countries, smartphone penetration in adults in the US is about 77%. And because of the ubiquity of smartphones and the granular spatial temporal data that devices create, using mobile data as a representation of population mobility patterns has become increasingly interesting to location intelligence companies like CARTO. So now there are important privacy concerns that we need to take into consideration when we're using mobile data, even if it comes anonymized to us. And as we go through this analysis, I'll also be pointing out the ways in which we can further anonymize and aggregate the data in such a way that we can protect both the privacy of the users and also turn the original data into more useful and meaningful information. So some of you might be wondering whether this mobile data is actually representative of the overall population, since not everybody has a smartphone. So in order to check whether we can use this data as a proxy for overall population, we compared it against census tract population counts in 2016, which is the most recent year for which there is census data. We can see that there's a pretty good linear relationship between our mobile data, our mobile device counts, and census counts. And this chart is just made using some pretty basic methods of comparison for the purpose of demonstration. In our actual offerings, the methods that we're using are a little bit more sophisticated. So let's take a look at MassAv again. This is a map showing the original mobile data pre-aggregation. We've extracted some travel modes for our user pool based on travel speed and some initial temporal information. So for instance, we can see here that we've already created the car and pedestrian travel modes, and we can see some patterns in the hour of the day and across days of the month. However, as it is now, we still don't actually have a count of trip volumes on MassAv. Here we've joined the same data to road segments on and around MassAv. The thickness of the lines here corresponds to the number of trips we see on the segment every hour between 2 and 7 p.m. And so as a side note, we might typically want to think about normalizing these numbers by the length of the road segment, for instance, to get a density measure. But here I'm not doing that because I'm interested in finding the actual number of trips along the entire segment. So let's see what's happening here. Using the mobile data, we're able to approximate vehicular traffic counts for 4 Fridays by the hour. And so this chart on the right here is essentially showing us a static version of what we see in this animation. So for instance, we can see that the peak volumes are around 5 p.m., which is probably when people are commuting from work. The pedestrian patterns appear quite similar. And so what do we gain from this information? We now have a dynamic estimation of the number of both pedestrians and car trips on the road, and thus the number of trips that we would potentially be impacting. And so for these numbers, we estimate that there are on average about 7,800 pedestrian trips and 7,500 car trips per hour, which is about 125 car trips on the street per minute. This sounds reasonable and is in the right ballpark of open data estimates from 1994, which is unfortunately the latest years for which I could find open data. So while we love open data, it's not always possible to get the right time and the spatial selection that we need. With mobile data, we can create and compare these slices with relative ease. And so using these numbers, we now have an estimate of the number of cars that we'd take off the road per hour and a gauge of the number of pedestrians who might benefit from the road closure. And so now let's take a look at where people are coming from and then where they're going to. And the reason why we want to understand this is because we want to get a sense of what kinds of trips we're affecting and which other roads are going to be directly impacted by the car ban. And so the way that we find these larger effects is we look at the 2 hours before and after a trip along this segment of Mass Ave. So this map shows the 2 hours before and 2 hours after trajectories of all the approximately 1,500 users that we saw along Mass Ave. And if you remember Stuart's talk from yesterday, you might notice that this map looks a little bit different from his Boston mobile data map. And that's because every point in this map is someone who went through Mass Ave on Fridays between 2 and 7 p.m., and thus this map radiates out of Mass Ave. So we were able to see spatially the wider physical effects of a car ban, but what about who we're going to potentially be impacting? We can learn more about these, and what can we learn more about these users? Since we have data throughout the day and night, we can infer at the census tract level where these people are at night, and thus the general region where they live. And so this map shows a count of the aggregated user residences joined to the US Census Tract. We can see that overall, the drivers appear to be coming from further away and from a wider range of regions than the pedestrians who are mostly Cambridge locals. So it seems like kind of an obvious breakdown, but that's often what we want to do in our analyses, like confirming the intuitive and the obvious. I think we can conclude something important, though, which is that the initial hope of the car bans was to encourage more pedestrians to use the street. If our analysis had found that all of our Mass Ave pedestrians were from the suburbs, then it's unlikely that our car ban would do that much. However, as we found that the pedestrians who use Mass Ave are also generally kind of around the neighborhood, we can assume that the car ban would, in fact, directly encourage more walking, running, and biking from locals. The next data set that we're going to bring into our analysis is actually census data. So despite the fact that this is one of the oldest and more standard data sets people use out there, we want to show that there are new methods that we can use to understand census data from a novel and potentially more informative angle. So let's take a short detour from our case study. This is a map, this is a population choropleth map for the greater Boston metropolitan region. This is how we typically see and understand census data. This is how we typically understand census categories, one at a time. And by the way, these are the census characteristics for all of our Mass Ave users. Now, this information is helpful, but what if we combine these categories to create groups? I think it's easier to create narratives about different groups of people because it helps us understand and explain to others who we're impacting. So what if census maps look like this instead? Here what we've done is clustered census categories based on similarities in the data. And actually, we've written about a very similar method before, developed by researchers Alex Singleton and Seth Spielman. The categories that result here are actually already part of CARTO's data offerings for the whole of the US. So this is not a process that you'll have to repeat yourself. So essentially what we're trying to do is we're trying to find bundles of category similarities. Here, I'm making a three-dimensional chart of 3 of our census categories: race, home ownership, and the number of kids. And you can see that the points within each group kind of gather together, more or less. So this green region over here corresponds to that blob of features on the chart. And so what does this grouping or clustering give us? It gives us these very descriptive groups. We can intuitively understand, for instance, that a group of wealthy suburban white homeowners, like group 0, makes sense as an entity. And similarly, group 4, which is middle-class urban renters composed of a mixture of races and without kids, also seems like a group of people that we might recognize. And so as a side note, this method, importantly, also gives us a smaller margin of error in each of our census estimates than if we didn't group them. So we were able to break down our drivers and pedestrians to different groups, to the different groups that I just showed. And we can see that our pedestrians are primarily composed of those middle-class renters from diverse races who live in urban areas and don't have kids. And that makes a lot of sense since there are a lot of students and young professionals in the area, in the Cambridge area. On the other hand, there's a significant chunk of drivers who are the kind of more wealthier suburbanites. and the rest for both drivers and pedestrians both have a fairly equal amount of other upper middle class populations. So we can see that our initiative will have a differential impact on our two groups. The last example of a new data stream that I'm going to talk about today is MasterCard credit card data, which MasterCard gave a great talk about at locations. And I think this category of data is super interesting because it provides a new lens through which we can understand activity. We have mobile device foot traffic data to tell us how people move about, and now we have this new type of data to help us understand what they're doing once they get there. Commercial activity makes up a large portion of how we can describe people, and now we have data for that. So how can we use this data set in the context of our traffic impact study? This map shows the locations of the venues from our Boston area data set in white. We've clustered these venues to find these kind of micro regions of commercial activities. So here's where I tell you that I live in Cambridge and in the neighborhood of our case studies, which is partially the reason why I'm doing this analysis here. However, knowing the area quite well, I can tell you that these micro regions are pretty accurate. So we also know the industry category of each venue, which then allows us to look at the mixture of industry breakdowns in each of these clusters. What I'm showing here is the industry mix in each of our cluster of venues alongside the number of venues in each cluster. So this purple over there is the restaurants and food category. We can see that across clusters of different sizes, it generally makes up about 25% of each cluster, which intuitively makes sense. So now going back to our impact study, we recall that we want to understand the potential impact of on local businesses. Here we're looking at all the business clusters along Mass Ave and their category breakdowns. And the size of the clusters here represents the number of venues. And this here shows where our pedestrians have stayed. The size of the circles here represents the number of stays within each microregion. And very briefly, the way that we define stay locations is by a distance and time threshold. So any pings that are within both these thresholds are grouped. And then the centroid of these points is marked as a stay location. So now we can start to tease out the relationship between the number of venues a cluster has and how many visits the cluster gets. Oh, sorry, back please. Thanks. So from this cluster, we can create a multiplier for how many pedestrian counts will, how much pedestrian counts will increase in each cluster. And we can see that you can see that at 36 or so venues, we have about 100 visits. And this is a linear relationship on a logarithmic scale. And then furthermore, and this is not something that we've shown here, but something that we kind of talked about before, we have a gridded data set of spend indices, which will then allow us to estimate the monetary value of how much revenues can potentially grow with increased visits to these areas. So to do a quick recap, what did we do just now and how did we enrich our understanding? We started off with municipal data, which helped us narrow down our study conditions. We used anonymized mobile data not only to count the number of cars and pedestrian trips in Mass Ave, but also to get a sense of where they're coming from and where they're going to. We then layered census data onto the mobile data to understand demographic profiles, but from a new methodological lens. And then we also used credit card data to see how businesses might potentially be impacted by this initiative. And there are other data sets, part of CARTO's data offerings, such as events data or weather data, that would have given us even more different perspectives in this study. So this is kind of a simple traffic impact study, but nevertheless, I was able to do this in a few days by myself, just on my laptop. No trip to Mass Ave needed. You can imagine the comprehensiveness that we can achieve with a little bit more time and effort. This, compared to more traditional methods applied in traffic impact studies of manually collecting the data and only at certain times and locations, means that we can create a fuller and faster understanding of our problem and solution space. For businesses, that means money, time, and human resources saved. Further, for this traffic study, we added many more useful dimensions of consideration than what is typical, because we could and with ease. In CARTO's data stream offerings, we've created an intelligent process of cleaning, modeling, and aggregating the data into a useful tool, as well as streamlining data delivery through one source. Adding more layers of information can now happen much more easily. And lastly, I think that we've demonstrated that these data sets can be used in very flexible and thus, they're very flexible and thus can be applied in many different kinds of sectors, from real estate development, perhaps, using this data set to describe neighborhoods, to retail and sales territory management, to healthcare, through health and mobility analysis, to government and data-driven policy decisions. And why can we do all this? Our new data streams and new methods gave us spatial specificity, temporal flexibility, and the ability to scale our analysis with ease to study anything from one road segment to an entire city or region. And so where does CARTO fit into all of this? Going back to our cake analogy here, which I'm really milking, we have the tools and equipment in our software product offerings to bake the cake. We're the cooks in the kitchen with data scientists, engineers, and professional services support who are experts in spatial data. And this is just a sampling of the spatial data science projects that we've worked on. And we deliver you the results, a data layer cake, ready to consume. And lastly, with the beautiful maps that we make, we also give you the cherry on top. Thanks.